I know what you're thinking. You're sitting here, staring at that function going, gee, I wish I knew what that x was. Well, lucky for you, I'm going to show you how to do this problem in 6 easy steps. Step number 1, take that c value and get it to the other side. So the c value in this case is negative 20. So both sides, we're going to add 20. Now, the purpose of what we're trying to do here is we're trying to find that perfect c. But before we can start trying to figure that out, this a value has to be 1. So we take out that 1/3. The 20 stays the same. And the 1/3 is now on the outside of that quantity. But here's the trick. In order to take the 1/3 out of that -2, you have to divide -2 by 1/3, which gives us -6. Now, I left that blank because we need to find that c value using a certain formula. And that bad boy is b divided by 2 squared. Now the b in this formula is -6. And that gives us 9. Now when we add this 9, we also have to add it to the other side. But it's very important that we take this 9 and times it by that 1/3, which is 3. So we add the 3 to the other side. Which gives us 23. And it's equal to 1/3 times the quantity x squared minus 6x plus 9. Now, it's easy enough to take this and put it into a different form, which we need for the final answer. Now for this, we're going to have the 1/3, and it's going to be its factor. And we find that by taking this -6 and basically putting it in half. Now I need to make sure it's squared because it's what factors to make this. Now, from this point, it's easy smeezy algebra to get that x by itself. So, we divide by the 1/3. Do the same thing over here. Now these are fractions, and it's going to be obnoxious, but it's going to be challenging. And if we use fractions, we get the most exact answer possible. Enter that 0.3 billion times, it's going to be a little off. And come on, that's no fun. That's not math. Alright, so if you take that 23, when we divide it by the quantity of 1/3, which is basically tripling it, we get 69. So 69 equals the x -3 squared. So now, if we were to do the algebra, we have to square root the 69, and then we have to move the 3 over. So we're going to have x equals, now remember, when you square root, you have both a positive and a negative answer. So we're going to have a positive and a negative square root of 69 plus 3. And that's how you do it, ladies and gents. Completing the square.
Teacher? Yeah, if you take the quantum theory of the c value, it proves Faraday's law, and the answer is 3, and you're wrong.
I mean, you said some smart things in there, but really, that made no sense. You're just trying to be smart. Please just sit down. Now I know what you're thinking. You're thinking, Josh, that was too easy. I can get that down no problem. Well, let me give you something to make your head spin. You see this crazy bad boy with 1, 2, 3, 4, 5 terms? Oh yeah, we're finding the domain. Well, we're given the x's at -2 and 4. And how do we do this? Oh, I'm glad you asked. A little thing called long division. Remember in 3rd grade that subject you really struggled with? That long division? Well, now it's gotten bigger and scarier. But don't worry, children. I'm going to show you how to do it. Now, it's very important that when we do it, the x's go in order. So even though in this problem there's no x to the 4th power, we need to add that in there. So we've got 4x to the 5th plus 0x to the 4th minus 44 x to the 3rd minus 64 x squared minus 48x minus 64. Remember, the x's I gave you are -2 and 4. Now, in order to do this, we need to make this equal to 0. So when you take that 2 and throw it to the other side, that's going to be what we're dividing this by. Now, it's very important in these that the x's go in order. Now, what do I mean by that? Well, right here, we've got, goes from x to the 5th power, x to the 3rd power. So when we go to do the long division, we need to fill in that blank. Plus 0 to the x to the 4th power. Which, really, it just equals 0. But that's used as a placeholder. Now, remember, the x's that we were given were 2, or -2, and 4. Now, to do this, we need to make sure it's equal to 0. So what we're going to divide it by is x plus 2. Now, one of the steps is going to be long division. Putting that in one step is probably criminal, because it is a very, very complicated thing. But I'm going to simple it to 4 steps for you guys to do. Long division. I might have spelled division wrong. That's why I'm teaching you math and not English. But it's done in 4 steps. Divide, distribute, subtract, and drop. Now, that may sound pretty easy because it's just 4 steps, but it's a lot to do, and when you're doing it quite a lot, oh so very much, then you can get tripped up easily. It's easy to make simple mistakes. I know I do it. So when you do it, I don't suggest you use Sharpie, but I'm going to do it so it's easier for you to see, and because I have complete dedication to educating the viewer. So let's get this started. Now, if you remember from before, our 4 steps are divide. How that's done is you take this x and you divide this by x, which gives you 4x to the 4th power. Ba-boom. Now, the other step, distribute, is done because this part we put under this value is this times this. Now, I know what you're thinking. You're going, well, that's the same thing. We just undo what we just did. That's silly. Okay, yeah, it's kind of silly. But it needs to be done, because otherwise things don't work. And we like things working. So if you take this 2, and this is the other distribute, I guess you can say, we take that 2 and multiply it by the 4x to the 4th power, which gives us 8 x to the 4th power. Now here's where things get kind of crazy, because you're taking this, you're going to put in a quantity, and you're actually subtracting this. So if you take this, subtract the same value, you're going to get 0. Now because we like to be efficient, we're not going to write that 0, because, you know, psh. But this is what we need to write down. We take the 0 and we subtract the 8x to the 4th power, which gives us a negative 8x to the 4th power. Now we redo those 4 steps. We divide, so we got the negative 8, and you divide out the x, giving us x to the 3rd power. Now we drop down, this is the drop part, the other value. Now we do it again. So we take the negative 8x to the 3rd power, and we times it by that x. Once again, it's going to give us 0, but it needs to. And we take this value, times it by the 2, giving us negative 16 x cubed. Now remember, it's in a quantity, so that's what makes everything works out. So here we got 0, and right here we got negative 28. Now we take out that x. We drop. We distribute x times that. Now we take the 2 times the negative 28, which gives us 56. Now some of this math you can do in your head, but I have to kind of really think about it because I don't want to mess up in Sharpie. That's no bueno. So again, we get 0 here, and this side we get negative 8. So again, we take out that x, we drop, we times that, times the 2 and the negative 8, which gives us a negative 16. We got 0 over here, and this spot we got negative 32. Now at this point I kind of look ahead and make sure I didn't screw up somewhere, because it happens and it's sad. We notice eventually we're going to be putting this up here, and 2 times 32 is 64, so that's a good sign. So we take that 32, we drop down that 64. Ah, don't forget that x. See? Look, we're already going to make a mistake. You guys should have caught me on that. You can't. I'm kidding. It's a one-way video. Don't do that. It'd be silly. So we can bring down that 64. And Oh, do you see where I messed up? I did it again. I'm keeping you on your toes. There's no x there. There's no x. You're supposed to divide that out. We didn't. Now it's fixed. So now we take the 2 times the negative 32. 32. I'm cracking. I'm cracking under the pressure. But all's well and good because we get 0. So we've taken this polynomial divided by x plus 2 and basically just made it smaller. Now, what we want to do next, our next strategy is we're going to group. But in order to group, we need to have 4 terms. We've got 5 here. We need to do long division once again. Oh yeah, the fun, it never stops. Alright, long division numero dos. So, we gotta write over the answer we got last time. That bad boy here. Now remember, if you think way back to the beginning, we were given 2 x's. The -2 and the 4. This time, we're going to be dividing out that 4. So we're going to do this. We got that x. Remember, it's -4 because it has to equal 0. And we do it again. A little easier. We got less terms. So I'm going to go a little faster this time because I think you kind of got what's going on. We divide out that x. We times it by that x. Times -4 by the 4. Giving us negative 16. I'm a fool. I should learn math someday. 16 x. Rock and roll. Subtract quantity. Leaving us with 8. The reason I got confused was because I thought I saw this 8. I thought we were going to add 8. That didn't make sense. What a silly goose. Okay, we drop down. This is -28. Sweet. Now again, we take out that x. Boom. Times it back in. Now, -4 times the 8 gives us a 32. Which leaves us with 4. Don't forget those x's. They're going to disappear and they're going to trip you up. Learn from the mistakes I make. Alright, let's drop down that -8. We take out that x. We put her back in. We shake it all about. Just kidding. That was a little joke. I'm a full of them. Alright, we got 16 x. Which leaves us with 8. Drop down that 32. Don't forget to write the 8 to the x power. Take out that x, get 8. Multiply it back in. Now 8 times -4. Hold the phone. Hold the presses. It's 32. It's going to leave us with 0. We did it right. Hip hip hooray. Now this, if you've noticed, has 4. Which means we're going to group. And it's going to be great. But remember, when you group, it's important to remember that it needs to be, what's the word I'm looking for here? The same ratio. So 4 to 8, it's double. 4 to 8, it's double. It's also the same number. You probably could have saw that there. Alright. let's make some grouping happen. Get closer and closer. Alright, ladies and gents, here's the moment of truth. You gotta do some conceptual things. Remember what we did. Remember what it means. So the first thing we did was we divided out the x plus 2. The second thing we did was took out that x minus 4. So we're trying to finish this bad boy up. We need to write down all the things we factored out or divided out. So we've got okay. Now remember, now I gotta put in this answer, and that's what we're multiplying into here. And we got 4x cubed plus 8x squared plus 4x plus 8. Doesn't that look scary? Well, we made that look a little less scary, because what we're going to do now is grouping. So, how to do that is we're going to bring this down, because this is what we're going to actually be grouping. Now hold on to your hats, because one of the reasons that we, or not one of the reasons, one of the things we do in grouping is we put this into two groups. Boom, 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 and boom. A group in grouping? Yeah, I know, it's crazy. So, now what we do is we got to factor out the greatest common factor that this group shares, which is going to be 4x to the second power. Which is going to leave us with x plus 2. Now over on this side, we factor out, all we can factor out over here is just the 4. So we've got 4, and that leaves us with the x and the 2. Now here's where things get crazy, because it's tough to visualize what's actually happening right now, because you want to think that you're taking out 2x plus 2's, but you're really not. You're basically just taking that 1x plus 2 out of this. So really what you're left with is x plus 2, which gets rid of this and this. Now what you got left here are just these two kind of lonely numbers right now. So what you do is just smack those together in one thing. Now, that is this simplified a little bit. So you gotta remember to take these and bring them down here. So we got at this point is the x plus 2, the x minus 4, another x plus 2. What does that mean? Don't worry, we're going to get to that. 4x squared plus 4. They're not tipped over so you guys can see it kind of a little bit. case you were curious. Now, from this point, we want to make sure things are as simple as can be. Not conceptually, but, you know, simplified math terms. You know what I mean. So we're going to take this and we're going to take out the 4 from this. We're going to have 4. Which is going to leave us with just the x squared plus 1. And then we're going to take those other ones, bring it back down. So this is what we're looking at this point. Whole lot less scary, right? And what we do here is we find those x's. So from here, you're going to move over that 1, and then you're going to square it. So x equals -1. Make sure to square it. Then you got x equals -2. Oh no! I forgot. We've got 2 of these x plus 2's. What does that mean? Well, it means scratch all this junk. What was I doing? We gotta simplify even further. Squared. So what does that square mean? That just means when we get to the graph, it's going to do something a little different. Yep. So x equals square root -1, x equals -2, and x equals 4. Now even though there are 3 x's here, you have to remember there's actually 4 because this term is, well, not term, well, this is squared. So now we're going to start graphing this. Man, one day I'll get the ability to actually make a straight line. Oh, hold on. Hold the phone. So now we're going to graph. But because we got this square rooted, it's going to give us both a positive and a negative. Squeeze that in there like that. So now we're going to have this -2. And we're going to have this 4. And then we're going to have those 2 negative ones. And so now we gotta see what's gonna happen in the graph. So we gotta count up the degree. Because this is squared, we're gonna have 2. And because this is to the second power, it's gonna be 4. And then we've got this, which is just gonna be 5. And 5 is odd. So when they're odd, they're gonna be in a kind of line shape, either like that or like that. Now, this is even. The a value is even, which means it's going to increase. So we know the endpoints are going to be something a little bit like that. So now what's going to happen is it's going to go through all these. So it's going to go through the -4. And then because this is squared, it's going to bounce to that -2. So it's going to hit that -2. Bounce, and it's going to go through that -1 up to that -1, And ba-boom. Now we just got a graph, or not graph, but find the actual domain of this. So the domain, now how to figure this out is we just look for everything basically above the x-axis. So we've got, oops, make sure to make that a circle, because we've got, nope, not a circle. I was right the first time. Square brackets. Oh jeez, -4. Now, it doesn't actually like go below the x-axis at that -2. It bounces off of it. So really, the first time it goes under the x-axis is at that square root of -1. We're going to do a union. And then it starts off, square root of that -1 again, goes off into infinity. And there it is. All this hard work. Those 2 long divisions, the grouping, the graphing, the, anxiety, the flop sweat, the tears, the blood, the scariness, the cuddling your teddy bear. So I equaled that. So high five, because that was scary hard.
Excuse me? The word is pronounced remember, not remember. You said it over a sentence, and you said it wrong. Get a dictionary.
I don't see how my pronunciation has really anything to do with the math ideas I presented to you. Not really the most important part of this, really.
X ain't a number, it's a letter.
It's a variable. So what's a way you could use something you learn in pre-calculus to maybe use another class, for instance physics? I'm glad you asked, because check out this scary looking thing. So, express the acceleration of a car as a function of the distance it travels given a speed of 30 meters per second. Now, that may look really intimidating when you first read it. In fact, it probably makes you want to run away. That's what I would do. But, something a teacher taught me before, when you see big scary problems like this, whether it's math or physics, don't get intimidated by looking at a whole. Break it down to parts. So, one of the first steps is you have to find the formulas you're going to be using for this. Now, right now we know we're going to try and express acceleration. Now, something that uses acceleration, distance, and speed is this good old formula. You remember that. Now, basically what we're going to be doing is we're going to be substituting something in for that t, which is time. And we know, remember, this t is squared. And remember that t is equal to distance divided by speed. So how we're going to solve that problem is we're going to insert what we know t is into the other problem. So we've got acceleration equals 2d divided by distance divided by speed squared. Now we already know the speed is 30. So we're going to plug that in. Alright, so this is what we're going to be working with. Well, it's very important that when we do this, we simplify as much as possible. So we're going to take what we ended with before. acceleration equals 2d divided by d divided by 30 squared. Now, something to remember is that when you're dividing something like this, first of all, when we're squaring, we can just throw that in there. So acceleration equals 2d. Add in this so we don't get confused here. 2d divided by distance squared and 30 squared, which is 900. Now, when you're dividing something like this, it's basically the same as multiplying it by the reciprocal of what's in the denominator. Hey, if you didn't know any of those big scary words, ask a math professional. So, it's basically the same thing as 2d over 1 multiplied by 900 divided by d squared, which leaves us down here with 2d times the 900 over d squared. Now, those d's can just get taken out of both. So we can cross out that 2 and cross out that 1d. So in the very end, we're left with area equals 2 times the quantity of 900 over d. Do 2 times 900, which is 1,800, divided by d. So now, the car's going that 30 meters per second, which is like 70 miles per hour, and given any distance, you can find the acceleration given that simple little formula. Put that in your pipe and smoke it, Einstein.
I did E equals MC squared at age 2. This is complete child's play.
You're just pretentious. You don't need to just...
Hey, that's why I don't drive. I just put saddles on pigs and ride them.
It's not only unlikely, it's weird. It's unpleasant for the pig, probably. You're not putting his feelings into account with all this. You don't really... I don't really... And just in case you haven't got your fill of graphing things yet from that long division problem, check out this bad boy here. Find the relevant information and graph this rational function. Now, at first glance, this may look spooky, because you've got things you've got to factor here. You got this under the denominator. This graph is gonna look kooky. Well, it is. It's gonna look pretty kooky. But I'll show you how to interpret and figure all that good stuff out. So one of the things we got to find are the x-intercepts. Now the x-intercepts are when the numerator equals 0. So looking back what we got here, we got x plus 2 and x plus 10. So the x-intercepts are going to be when x equals negative 2 and when x equals negative 10. Now the y-intercepts, just 0, or none. It doesn't cross the y-intercept, or doesn't cross the y-axis. Another thing we got to find are the vertical asymptotes. Now, the vertical asymptotes are when the denominator equals 0. So we've got x plus 7. So, x equals -7. Now, also, because we got that x out in the front, if this x out here equals 0, it doesn't matter what's in here. The whole bad boy's just going to be 0. So another vertical asymptote is when x equals 0. And another thing we got to find are the horizontal asymptote. Now this one's pretty crazy to look and figure out, because you're going to look at the original thing you're working on. Now we're going to look at the coefficients of the a value, which in both of them are 1. So what you do with that information is over here, since both of the coefficients, I wish I could talk, coefficients were 1, you've got 1 over 1, which is just equal to 1. So, because of that, the horizontal asymptote is at 1. If one of the coefficients were 2, like, what was the numerator? If the numerator had a coefficient for the a value of 2, then it'd be 2. Or if the denominator did, it would be 1/2. So that's how that works. And then what we have to do is find the behavior. Well, before we do that, let's go ahead and start graphing. Let's just get that graphing all the way underway. So I'm going to try my best to keep both the graph and the information we had from before up here, so you can kind of see how the information we got before relates to the graph. So we've got a line segment. Not a line segment, it's a graph. I'm a fool. And we've got the x-intercepts at -2 and -10. Now, the asymptotes are represented by little dotted lines. And we've got 2 vertical ones at 0. That's kind of hard to represent because there's already the y-axis there. We're just going to do as close as we can. And then at -7. And then remember, we got that horizontal asymptote at 1 on the y-axis. I'm going to say that part's 1. I'm going to go ahead and do some dotted lines. Now, we know the asymptotes are going to create spots here and here. We know it's got to be here because it's going to cross that x-axis. Axis. So this part of the graph's going to look something like that, which means the other one has to be over here. What goes on the middle, that's a little bit of a tougher process to come through. So what we're going to do for now is we're going to pick some random value between that -7 and that -2. Let's go with -5. It could really be anything in between there. But we're going to take the -5 and we are going to plug it into what we got right here. So let's go ahead and just do that right here on this page. So we've got negative 5 plus 2 and x plus 10. Ooh, but that x is going to be negative 5. That's the whole point of what we're doing. And then this x is just going to be represented by the negative 5. Easy enough. And we got that negative 5 plus 7. Now, we got to look at what that's going to give us. So the negative 5 plus 2 is going to give us negative 3, which is negative. We don't even have to remember what it gives us, just whether it's negative or positive. Now this one over here, we add that 10, it's going to give us a positive 5, which is positive. And over here, negative 5, not a toughie, negative. Negative 5 plus 7, it's going to give us a positive 2, which is positive. We relay this over. Now, what you got to do here is you got to kind of multiply across. A negative times a positive, that's going to give us a negative. Again, negative times positive is going to give us a negative. Now, what happens when you got a negative divided by negative? It's going to give you a whole lot of lines there. Hope you realize that this is the equal sign. These are negatives. And dividing a negative by negative gives us a positive. Now what that positive tells us is that in the graph, remember we picked a spot right here, a number, which is negative 5, and it's positive, which means it's going to be on the positive side, which is going to be, let's see here, yeah, I'm sure it's going to be over here. Now we do the same thing with a number in between the vertical asymptote of 0 and the negative 2. Let's go with negative 1. And again, we kind of do the same thing, where every time there's an x, we plug in, we chose negative 1. So, you have got negative 1 plus the 2 negative 1 plus the 10, just negative 1, and then negative 1 plus 7. Now, you're going to go ahead and do the same process here. This go ahead and gives us a 1, which is positive, 9, which is positive, and then we've got, this is just a negative, nothing to do there, and positive. Now here, a positive times a positive gives us a positive, and of that, I'm positive. Oh, humor. And then this negative times a positive gives us a negative. Now, a positive divided by a negative gives us a negative. Which means, over here for the graph, since it's negative, it's going to be down here. So, the graph looks a little something like this. Kind of curves through this spot. Ba-boom! Goes on forever. So, now, we started with this, and we were able to find all of this information. And from that, we're able to make this graph. Aren't you the smart one?
That graph is too messy to be readable. Use a ruler.
Well, it's just a, you don't need, it's a sketch.
You said asymptote.
No, that's just not appropriate. Hope you did some math, learned some, enjoy doing it.